Hello everyone, and today we will start with the next part of our series, and that is VEX and VOP. These two are really important and a bit difficult to understand at the beginning, but I will make sure that I will do my best to make you understand. And if you want to understand Houdini at the very base from a deeper level, then you need to understand these two, because without these, Houdini is like nothing. This is the spine of Houdini where everything works on everything works on these two. So you can create something by notes, it's okay, but these are really important and crucial if you want to go to at the next level. So in this video today, I will create a project based on these two, and I will explain what is VEX, what is VOP, how you can use them, and I will in that project I will create a project first, obviously, and in that project I will create an attribute on the geometry by VEX and VOP also. In the past, we were creating attribute by the attribute create node, right? By that simple node, but now we will create the same attribute by VEX and VOP. Let's start with understanding what is VEX and what is VOP. So first, VEX. What is VEX? VEX is vector expressing language, and it's Houdini's own language. And from this language you can create, modifies, and controls the attributes on a geometry. And it can control like anything: color, normal, shader, anything and everything in Houdini you can control by this vector expressing language. And you would say, why do we need this language to work in Houdini? We can also work with nodes, and we have already worked with nodes. But I will give you an example. Let's say you have a scene and you have millions of points scattered on that scene, and now you have to change the color of thousands of points in that scene. And now you have three options. You can do it manually by selecting each point and giving it a color. You can do it by nodes, and you can use this VEX vector expressing language, right? So when you do it manually, it would take forever, forever. You can do if you want, but thousands you can do it if you want, but you can do it also by nodes, and it would take much less time, but it would take a huge time, I must say. But here we have VEX, and we can have the freedom we want with this language. It gives you the freedom that the nodes and the manual part cannot do. That's why it is important. And if you want to learn Houdini on a deeper level, then you need to know about this VEX language. And what is VOP? So VOP is like VEX operator. So it's same as writing VEX, but you are writing VEX by nodes, and that is VOP. You are doing the same, you are writing your language but by nodes. And let's see in our scene, and you would understand this better. I have created this geometry container, and inside this I have created this scene, and I have also created these two nodes so you can understand these two better. And first, let's read this VEX vector expressing language. It is Houdini's programming language used to control points, vertices, color, normal, attributes, volume, shaders, everything. I already told you everything. You can write this also, and you can screenshot this so you can remember this. And we have VOP, VEX operator. It's a visual node based way of writing VEX without typing codes, right? And in this scene, I have created this sphere and I have given it two nodes, and I will like tell you what these two nodes are and how it works. And first, let's say I just created a sphere SOP, and this is also a SOP, and this is also a SOP. Everything we do in this geometry level, we work with SOP, surface operators, that creates or modifies the geometry, right? I have already talked about this. And let's say how we can type, where we can type our VEX language. So when you click this, you see we don't have any area where we can type our language, right? So we have this attribute wrangle node. And this attribute wrangle nodes give you the freedom to write the VEX language. It gives you a space where you can write your VEX language. And where it is, hit P, like in your parameter window, you have this VEX expression area. Here you can write your language and you can modify this geometry attributes. So this is our attribute triangle, and we have different types of attribute triangles. Attribute triangle, it is a like general wrangle, and we have detail point primitive. So this is a general attribute triangle, and you can change the run over to primitive point vertices number. And what is are these? Let's create a point wrangle, and you see these totally looks same, and I would say that these are same. This is just a shortcut to create a wrangle on a run over where you want. Let's say I want to change this to vertices. You can change it to vertices, and you can change it also to vertices. It just give you a shortcut, right? So if you want to like type your VEX language on the attributes of the primitive level, so you can create a wrangle and change it to primitives, or you can directly create the wrangle primitive. It's just a shortcut, right? They all are the same. Now now I will create an attribute by writing the VEX code, but later. Now we have VOP, node based VEX language. Like you are writing the VEX but by nodes. Okay, what is this? You see VOP, oops, delete this. VOP, you see these, and these are the same. Run over points, primitive vertex, these are the same. I just explained here. This is also the same. Inside this, I've already created two nodes so you can understand it better. I will explain it. Inside this, you have these two, and these are not SOP, these are VOP nodes. So here VOP nodes, these nodes like write the VEX language but in nodes. You will create nodes here, and like behind the scenes the VEX, you are creating the VEX. That's why these are VOP nodes, because we are working inside the VOP. And first you would see two, like these two VOP nodes. And what are these? So you have this sphere, right? And inside this, how would you read the attributes of the sphere? You need something, right? You need a point from where you can extract that attribute so you can read it. This is geometry VOP global. From this you read the attributes. We have different types of attributes, and these are like default ones. And from this you can read the attribute. Let's say you want to read the time or color diffuse, so you have this point from where you can read the value of the color diffuse of this geometry. I hope you understand this. This is really important. So we need to, if you have like any questions, just leave in the comment, and I would look forward and uh, try to solve your query. And we have this from this node where from where we read, and this node from where we write. So everything you do, we do between these two, and you read from this, you make the changes you want by your nodes, and you like write those attributes values back on this geometry. Right, this is just input and this is output. Let's say read and write. Now I want to like uh, share something here. Let's create what we already wanted to. First, let's create a constant. Don't ask anything right now, just do what I'm doing, because we need to understand the basics first before going in the deep. We have this constant. What is a constant? It's just a number. Number, just a number. Value, it's just a value. It does nothing. It just have a number and a value. Just a value. So we have this constant. It's a value, and you see we have different constant types. I know these are a lot, but for this video, let's focus on these two. We have a float and we have an integer. And I have already like write about this constant, and what is a constant, you can read it here. A node that holds a one fixed value. It doesn't change unless you manually change it. A number sitting in a box. Like just give me a number or a vector color that always stays the same. Just a number. Okay. And let's create and wait, first we would understand these two. Float. What is a float? I would create another notepad, and in this notepad I would tell you what is float. Float, a number with decimals. With a decimal. For example 1.1, 1.2, 1.3, 1.45, 3445, this. And let's say we have, and what if we don't want a number with points? 1, but how can you write 1 but in float? 1.0, this is 1 but it is in float with a decimal. And also I would just copy this here, and and inside this, let's say what is an integer, right? Because we have an integer option over here also. So what is integer? Integer is a number but without the decimal. Let's say 1, 2, 3, 4, 5, 0, a whole number, right? This is an integer. Simple definition is an integer. This is this. A number. This is just a number. This is number with points, and integer is just a number. So what if I'm an integer and I type 1.4? This would be 1. 1.5, this would be 2. 1.6, this would be this. We are just making it average, right? So we already know about this, that above 1.5 we consider it 2, and above like below 1.5 we consider it 1. So now when we know about this integer and float number, we can delete them. And what is this constant doing here? This is just a constant with value 2. It's just a number. It is doing nothing unless we want it to do something. We will create a bind export node. I have told you about this, that this is a write node from where we write the attribute back to the geometry. If we are making any change in any attribute, we need something so we can write it back. This node does the same. This node also does the same. Now we have two nodes that does the same. We have also a bind node that reads the attribute from the geometry. For this, just focus on this bind one, and this is our bind export. Let's say how I created this, just bind export, and we have our bind export. What if I connect this value to this? This is also export node. Then why we are connecting this to this? This is also exporting the attribute back to this. Let's just open its parameters. Then why we are not connecting this to this? Because this is also a write node that writes back the attribute back to the geometry. We have particular attributes here, but by this we can write any attribute. We can write new attributes. We can read the new attributes that are not here by the bind node, and we can write back by this bind export node. So when I connected this to this, what happened? When you go inside, let's say a float value, a number with points, right? Let's say we have this 2.1 value. Give this a float 2.1, and we have connected this to this float. Let's type new attribute, and what we did, we created a new attribute, a float value, and where on the primitive level we have created a 2.1 value, a new attribute with them new attribute float value. And when you go at your geometry level, and you would see when you hit the geometry spreadsheet that we have our new attribute we just created with our VOP, and that's really good, right? And I have already written what is this, so you can read it here. Used to write attributes back to the geometry, it can create attributes only when it doesn't exist already. We are creating a new attribute because it doesn't exist here. This name new attribute doesn't exist, that's why we are creating a new attribute. Bind used to read attributes from the geometry, and constant, a node that holds a one fixed value. It doesn't change unless you change it, right? We have explained this. So now we have created a new attribute with our VOP onto the geometry, and you can see it right there. Let's create the same with the VEX expression, right? So we need a value, we need a name, and where we want it to be. So for this, first I want to make you understand something. With this VOP node, we can change the value of the attribute that already exists. For example, go to your VOP and let's create an attribute create and put it right there. Let's say primitive level and float is okay. Give this 1.2 and name new. Okay, and when you go inside this, and if you want to change the value of this attribute we have just created, you can go to your bind. We have this constant 2.1, give this 4.1. We will change it and we have created a new, and when you go back you can see we have just changed the value of our attribute that we have created here, primitive 1.2. Now we are changing its value to 4.1 from the VOP. And now let's create attribute from the VEX expression. What do we need? What do we need if I want to create the attribute by this VEX? First, we need what it would be, a float or an integer. Let's say float. Okay. Now at the rate, which is attribute, what its name would be. I want to have a wrangle, or we can say VEX, because we are creating it by VEX. It's just a name. You don't need to. You can say attribute new, right? And equals to its value. Let's say 6.2, 6.3, and these to finish this. Now we have just created an attribute by this expression, and we have created our first VEX code. And what if I want to change the attribute here new, the attribute new, to give this different value? Can we do it? Let's see. Wrangle primitive, because it was on the primitive level, right? And this is also on the primitive level, and this is also, this should be on the primitive level because our attribute is on the primitive level, and this is a float value, so we have to tell this that it is a float value, because we cannot change, like we cannot have here an integer because we want to change the float value. You keep this in mind, right? So what it was, a float value, so we want to change the float value, so we cannot give the integer value, so we have to give the float value at the rate. What's the name of the attribute? New. And what do you want the value to be? 2.1. And just finish this, and now we have our new value. So in this video we have learned about VEX, VOP. We have created our attribute through VEX and VOP. Both we have changed the attribute of a already existing attribute, right? So I guess this is it for this video, and in the next video we will continue with this, and I hope you're doing well, and keep learning and keep creating. That's it. Thank you.